For my ENME 351 project, I decided to build a photoplethysmography cardiograph, aka an optical heart rate monitor, aka that thing they put on your finger when you go to the hospital. So here we have our heart rate monitor. We see on the bottom right side we have a red LED attached to a photoresistor. We have a potentiometer that is to control the sensitivity of this sensor. We have a single pole, single throw switch that's hooked up to our DC motor that's going to be controlling the translating paper that our servo will sketch the heart rate waveform on. That is all hooked up to our side of this breadboard. We have some signal processing, a few op amps, an active RC filter, decoupling capacitor, a few other things. It's all fed into our Arduino. On our processing component, we see we have error message saying it's calibrating, it's searching for a human. We have our waveform and the beats per minute in the bottom right. We're gonna try this out at the current sensitivity. We're gonna put our finger on the photoresistor. Wait for it to detect. We see that it is not detecting our heart rate. So what we're going to do is we're going to turn the sensitivity up just a little bit. Put our finger back on. We see the error message went away after it detected a certain pre-programmed number of heart rates. We see even though we have a few heartbeats that are lower in magnitude than the others, and a little bit of noise in there, we see that we have a steady heart rate around the high 60s to low 70s. We're going to maybe want to turn the potentiometer down a little bit, decrease the sensitivity, get rid of some of that noise as well. You see we have a nice steady heart rate around 68 to 71. We're going to turn on this translating screen right here. We see that after we stop for a little while, take a step back, processing will fail to detect a certain number of heart rates. It'll go back into calibration mode, searching for a human. Beats per minute is NA. We're gonna walk back up to the machine, put our finger back on. We're gonna give it time to calibrate. And just like that, it calibrates back to our current heart rate, high 60s, low 70s. And that is the optical heart rate monitor.